Okay, so remember our FOILs, okay? So remember that x plus 2 times x plus 2, x plus 3, sorry, it was x squared plus 5x plus 6, okay? First, outer, inner, last. Now what happened for the middle term, remember, this came about by 3 times x and 2 times x. So you've got a 3x for the outer and a 2x for the inner. That's the 5x, okay? So if x plus 2 times x plus 3 equals x squared plus 5x plus 6, then obviously x squared plus 5x plus 6 must equal x plus 2 times x plus 3, okay? But how? If I give you this trinomial, this x squared plus 5x plus 6, how can you get it to the x plus 2 times x plus 3? This is factoring. So again, I suppose the top line earlier on is multiplying, okay, and this, kind of think of it as dividing, but what's the factors, okay? So I'm factoring x squared plus 5x plus 6. Right, let's have a look. Let's look at this. I'm just going to throw this here. Right, what's two numbers that make 6 when you multiply, that make 5 when you add? 6 when you multiply and 5 when you add. 3 and 2. Right, let's write those down. Those are two numbers. Okay, what's two numbers that make 15 when you multiply? It makes 8 when you add. 3 and 5, 5 and 3. It doesn't matter which way around you write them. Okay, those are the two numbers. How about over here? Right, two numbers, negatives now. Right, two numbers that make negative 21 when you multiply. So one's got to be positive and one's got to be negative to make negative 21. They make 4 when you add. Well, 7 and 3 makes 21. But I need to get to positive 4 when I add them. Okay, here we go. Positive 7 and negative 3. Think about it, yeah. 7 times negative 3, negative 21. 7 add negative 3, positive 4. Okay, so again, I'll underline all these kind of little solutions I've found. Two numbers that make positive 16 when you multiply, that make negative 10 when you add. Well, here's the thing about this. Two numbers that make positive 16. Just like if we look at the top two examples, they're all positive. We've got two positive answers. So positive 3 and positive 2 for the first one, positive 5 and positive 3 for that second one with the 8 and the 15. Now don't forget that two negatives when you multiply can make a positive answer, and that's the clue for this. This is this. It's negative 8 and negative 2. Because think about it, negative 8 times negative 2 is positive 16, but negative 8 plus negative 2 is the negative 10 I'm looking for. Okay, so why are we doing this? Well, this is how you do these factoring trinomials. Look, here we go. I'll go back to that again. It's this. It's the x squared plus the 5x plus the 6. Okay, what's two numbers that make 6 when you multiply, 5 when you add? It's 2 and 3. Okay, so that's how you write these. Of course, the x and the x at the start is how you've got the x squared. It's these numbers I'm looking for, these coefficients, okay? There you go. So let's have a look at some more of these. Remember this one? The 8 and the 15. We thought 5 and 3 for this one. Let's have a look at it in work. So two numbers that make 15 when you multiply, that make positive 8 when you add. Well, again, the x and the x is the x squared. These are all positives. It's 5 and 3, remember? 5 and 3. Okay? Based on what we did on this slide here. Right, I'm going to translate this one now into an equation. Here it is. X squared plus 4x minus 21. What's two numbers that make negative 21 when you multiply, that make positive 4 when you add? What was it? 7 and negative 3? Right, so x positive 7 and negative 3. It doesn't matter how you write these. You could write the x minus 3 first and the x plus 7 second. Okay, 2 times 3 is 3 times 2. Two numbers that make positive 16 when you multiply, that make negative 10 when you add. Again, there's the x squared, x times x. What was it again? Negative 8 and negative 2. Negative 8 and negative 2. Right, okay, now here you're going to see some, so remember we've been factoring trinomials, three things, x squared, x's numbers, okay, at the end. Look at these two at the end. These are binomials, okay, they've only got two terms. But you can still kind of think about this. Look, the x squared is still an x times an x. This bottom one, an x, whoops, horrible x, times an x. Now then, okay, let's just jump to the end. What's two numbers that make negative 25? That's all I'm going to say. What makes negative 25? It's got to be 1 plus and 1 minus. Well, surely 5 times 5. It could be 25 times 1, but when you do the FOIL, you'll end up with some x in the middle. There is no x's in the middle. Well, here's why. Plus 5 and minus 5. And if you think about it, that's two numbers that make negative 25 when you multiply, but make 0 when you add, negative 5 and positive 5. That's why there's no x term in the middle. Okay, so think about this next one, x squared minus 100. 100? Well, you could say it's 50 times 2 and 25 times 4, but they're not going to make 0 in the middle, are they? It's positive 10 and negative 10, because one's got to be plus and one's got to be minus to make the negative 100. And of course, if you add those two numbers together, you'll get 0. You'll get nothing in the middle, all right? There's no x term like these have. Okay, look at all these. Okay, there you go. So, there you go. That is you factoring trinomials, but don't forget the special case, the factoring of this binomial, and that's actually called the difference of squares. Because think about it, you've squared an x, you've squared a 5 to get the x squared minus 25. You've squared the x, you've squared a 10 to get the x squared minus 100, okay? So this was called the difference of squares. But you can think of it as still you're factoring it into two parentheses, okay?